OpenSciEd, orientation video for external force applied to a solid simulation, student-facing video. A modeling tool shows a slider for model speed, buttons for setup/reset, go/pause, and remove external force. There are sliders for initial width, initial length, and external force. Graphs show outputs of deformation in angstroms, total energy stored in the electric fields, and net force magnitude on selected particle. A visualizer shows the model for the solid from the initial left edge, with dots connected by colored lines. The colors of the line ranges from red, when the bond has the highest repulsive force, to yellow, when the bond has the highest attractive force.
This model simulates the effects of applying an external force to a solid at the particle level. Press Setup Reset to initialize the model before running it. A very small sample of solid will appear. Each blue dot represents a particle, either an atom or group of atoms, arranged in a repeating pattern. The lines represent bonds between neighboring particles due to the electrical forces between them. Adjust either of these sliders to change the sample size. Use this chooser to change the type of material. Changing the material type doesn't change the ratio of external force to deformation, but it will change other aspects of the material behavior. All of these changes to the sample will only take effect after you press Setup Reset again. You can select the magnitude and direction of the external force you apply to the solid along its left side using this slider. Negative values will apply a tension force, pulling on it to the left. Positive values will apply a compression force, pushing on it to the right. This external force will be applied to the solid when you press Go Pause to start running the model.
The visualizer shows the dots getting closer together.
Press this button again to momentarily pause the simulation so you can inspect the changes that have happened up to that point in time. At this point in time, some of the lines between the neighboring particles have turned red. This key tells us what that represents. Red is an increase in the strength of the repulsive forces between the particles. You can tell how much the solid deformed by looking at this monitor here, or this graph. This monitor indicates the total energy stored in the electric fields between the particles at this point in time. This graph shows how that has changed over time. You can use your cursor to hover over any spot in the graph to get a measure of the coordinate values at that point on the graph. The bottom graph provides you a measure of the magnitude of the net force on the selected particle in the solid. The selected particle has a white outline. You can use your mouse to click on a new particle to select to measure the net force on when the model is running and not paused. This right panel shows you a vector representation of the net force from the neighboring bonds on the selected particle. We see no net force vector on it right now because the net force on it is 0. Watch that again when you remove or add external forces to the solid and resume the model.
Clicking Remove External Force causes white arrows on the particle to point to the left and shrink as time passes. The video ends. OpenSciEd.